Okay, today we're going to talk about the zero exponent rule. And it says that any number or letter raised to the zero power is equal to 1. So if we have a raised to the 0 is equal to 1. If we have the expression 8x to the fourth raised to the 0 power, it's equal to 1. All right. So how do we know that this is true? Because if we look at 2 to the fifth, right, that means 2 times 2 times 2 times 2 times 2, that's 32. And then if we go down to 2 to the fourth, that's 2 times 2 times 2 times 2, that's 16. 2 to the third, 2 times 2 times 2, that's 8. 2 times 2 is 4. Of course, we have 2 to the first power, that's just 2, so it's 2. And then 2 to the 0, there's really no way of writing that. It's just 1. All right. Same thing with 7 to the fifth, 7 to the fourth, 7 to the 3. If we keep moving down, what do we have left here, right? When we get to 7 to the 0. All right. It's just 1. So if the exponent of any base is 0, we know the simplified answer is going to always be 1. It's going to always be 1. So when we look at these examples, it says simplify the following expressions. Now, we know the previous rules, right? So we're going to keep that in mind. We're not going to forget about them. We're going to keep them in mind. So when we look here at x to the fourth times x to the 0 times x to the third times x, this x to the 0 is automatically 1. And we know x to the fourth times 1 is just x to the fourth. So we can rewrite this as just x to the fourth times x to the third times x. But remember, x is raised to the first power. And now we can apply which rule? It's the product rule. And what does the product rule say? What can we do here with our exponents? Do we add them, multiply them, subtract them? What do we do? All right, we're going to add them. So this becomes x to the fourth plus 3 plus 1. All right, 4 plus 3 plus 1 is x to the eighth. So our final answer here is x to the eighth. All right. We could have started simple, but it's okay. You know these other rules. So we're going to just keep moving. With number 2, 14 to the 0. Anything raised to the 0 is 1. So this answer is just 1. And we're done with it. Don't you love that? All right. When we look at number 3, we're going to observe it, right? And when I say observe, just look. We immediately see and notice 5 to the 0. And 5 to the 0, we know, is 1. So 5 squared times 1 is just 5 squared. And 5 squared over 5 squared can be written as 5 squared minus 2 by the quotient rule, right? Normally we say 5 squared over 5 squared is, oh, we just cross it out and it's 1. But why do we do that? Because by the quotient rule, 2 minus 2 is what we can do. And this becomes 5 to the 0, which we just said is 1. All right. Let's keep it moving here. All right, so when we get to number 4, all of this is a product in number 4. So we can just rearrange this. 2 times 3 times x squared times x cubed times y to the 4th. Right? Because this is a product. And then 2 times 3, 6. X squared times x squared, x to the 5th. Right? Because we add. This is the product rule, right? And then y times y to the 4th, y to the 5th. And you may be wondering, what does that have to do with the 0 rule? 0 exponent rule? Nothing. Just keeping you on your toes. All right. So, this next one says 4x to the 3rd y over 6x squared y. Right? So, we're going to keep this 4 over 6 for now. But let's look at our x cubed, x squared, and then y. All right. We know that we can use our quotient rule here, right? X cubed over x squared, that becomes x to the 3 minus 2. And then y to the 1, that's y to the 1 minus 1. And we're going to work with the 4 over 6 in a second. Now, 3 minus 2 we know is 1, so that's just x. And y to the 1 minus 1 is y to the 0, which we know is what? 1. Right? So 4 over 6 is, when we simplify that, 2 goes into 4 and 6, so that's 2 over 3. And that's our final answer. Well, actually, no, it's not. Our final answer is 2/3 x, period. Six looks real messy, don't it? But let's think about it. Everything in this parenthesis is raised to the 0 exponent, which leaves us with an answer of, yep, just 1. And we're done. All right, we're going to skip over this number 7, mainly because we need to keep it moving. All right, feel free to work